It's interesting when you talk about bringing the lawyers in. At Consumer Electronics Show, must have been in 2020, I went to a session. I went there primarily because Ralph Nader was talking, and I think the guy's hilarious. So I go there because I sort of want to hear Ralph Nader talk, and there he was being Ralph Nader, and he was talking about these legal issues and actually actively pushing the risk onto the OEM. And so one of the things that was being discussed is, if you own an autonomous vehicle, do you need a driver's license? And California already got ahead of this. They actually already passed that law. It says if it's level 5 autonomous, then you don't have to have a driver's license. But then that also says all the risk is on the OEM. Like, I've actively not been trained how to drive a car.
Right. I'm a passenger.
I am purely a passenger.
Like getting on an airplane, right? You
Right.
don't need to have a pilot's license to be a passenger in an airplane, I guess.
Right.
The same would apply, but someone ultimately has the liability there.
And I can only assume it's going to be the OEM. So yeah, as soon as the lawyers get involved, it's going to be even more complicated. So what option does somebody have? They don't want to. So they want to do this development. You want to do it right. I think as the lawyers get involved, I think we can agree. Maybe doing it on the public road is going to get riskier, or relying on customers to provide the data set might get a little more entangled, let's say. What other options do we have today?
So you of course have the on-road, but in a controlled environment. So what we call, or industry calls, a proving ground. So ACM, for example, an example. So you have a set of roads and different surfaces, you have different intersections and such, and so you can do a certain amount of creating real world conditions, but in a very controlled environment. That gives you, let's say, the ability to be a bit more repeatable, because you can restage certain, vehicle to vehicle type engagements, or with dummy vehicles or that kind of thing, set them up in such a way that you can really make sure that you're testing a particular feature. But you're still relying then upon people driving the vehicles, right? Because again, if we're talking autonomous and not fully automated, so you still have a significant amount of work to do a particular test. And so you've simplified one aspect, but you've perhaps made it a little bit less realistic. But you haven't really addressed the problem, because you can imagine the number of scenarios that you need to go through to ensure that what you're going to put out there on the road is safe are tremendous. I don't know the number, but it's maybe no one knows the exact number that ultimately gets you there. And so you have to look at, maybe it's a combination of the real world on the road, the proving ground, where you can do a little bit more focused studies. Clearly the simulation, so virtualization, so there's a lot you can do in these environments, testing particular functions of the strategy that you have, perhaps not in the context of the complete vehicle. So you can learn a lot, you can test a lot of things, but then you have to say, at what point am I comfortable that this pure simulated environment represents the real world enough that this particular maybe safety relevant thing is sufficiently tested there, or maybe I have to go and put it in one of these other environments. So those are kind of the more typical environments that we see, but then there are more and more interest in what we're used to, the more of the traditional lab space, where people are now saying, maybe I can make use of my powertrain dyno, my chassis dyno, and I can take these either complete or nearly complete vehicles or powertrains, put them into a controlled environment, now one that's highly automated, and now what I need to do is to find ways to either create the cues around the vehicle such that the vehicle believes that it's in the real world. So if you have vision-based systems, then you have a screen or screens, for example, with radar. So doing certain, stimulation there so that the sensor set is appropriately sensing the world around it. And now through simulating the environment, right, and being able to create through various means a bunch of your scenarios, you can now run these tests in a very controlled way for very long periods of time and go through multiple scenarios and have a very high confidence that you're capturing a lot of these particular cases. The other thing that you can start to do in these environments are, you can imagine, so emergency braking type conditions, or things that are really at the edge of where one would these corner cases that you don't want to put a person in that situation, but you know in the real world that situation will happen.
It's reality.
So now in these test environments, you have the ability to go much further to the edge and do tests there and have high confidence, right, that it's going to behave as you expect, but you're not putting people or equipment, right, at risk in the process of doing so. So it's really, I think the combination of all of these things, just rigorous engineering in the end, right, and rigorous attention to detail that ultimately is going to get you there. But I think anyone who thinks you can get there purely in a simulation environment, or anyone who says I have to test everything on the road, those are clearly two extremes that are not, I don't think, feasible to get us where at least consumers seem to be demanding and where the automakers seem to be headed. I think it's multiple pieces that are going to get us there.
So we're going to end up kind of where we are with traditional vehicle architectures, working all the way from simulation to on-road with all the steps in between.
Correct.
Right now, we haven't seen a lot of activity in that step you're just talking about, where you're stimulating the sensors and things, but in a controlled, sort of in a powertrain or a chassis dyno, as you kind of described there. But that does seem to make a lot of sense. It sounds complicated, though. I mean, radar's
There's
notoriously
definitely some
tricky,
technologies that have been made available more recently that allow us to do some of these things that I would say just years ago people thought were not possible or not easily done. Maybe very much in the pure research space, and we're now finding that we have several examples out there where this is possible. And in fact, we hopefully very soon will have some announcements of things that we're doing here in the U.S. In this very space with some of our customers, and look forward to being able to kind of share some of that at some point in the near future.
That's good. We should be talking about that stuff. So, well, Ben, it's been an interesting conversation. So, look forward to having a follow-up conversation here shortly. So,
look forward to it.
All right. Thanks, Ben.
Thank you.